Hey, how's it going? It's Mr. Riley. I'm going to go over the 1.5 notes real quick. These are different angle relationships that we're going to see in various problems over the course of kind of the end of this chapter, and we'll see some of these relationships show up over the year as well. So first off, we have vertical angles. So vertical angles are two angles that are across from each other whenever you have intersecting lines. So we have two lines that are crossing here. The ones that are across are considered vertical. So angles 1 and 2 are vertical. Angles 3 and 4 are vertical. What's also convenient about these is that they are congruent. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. After vertical angles, we have adjacent angles, which are ones that are right next to each other and share a side. So these two angles, angle 1 and angle 2, you see that they're very close to each other. In fact, they are only separated by one line, which makes them adjacent. A linear pair is a type of adjacent angles. Right here, they are separated only by one line, but they also are supplementary, meaning they form a 180-degree angle, or otherwise known as a straight line. So we have a straight line with one ray coming off of it. Those are going to be a linear pair. They are both adjacent and supplementary. Speaking of supplementary, it kind of goes in this category of supplementary or complementary angles. Complementary angles equal 90 degrees. Okay, so in this picture, we're going to consider that this is a right angle. So angle 1 is complementary with angle 2. So the measure of angle 1 plus the measure of angle 2 is going to equal 90 degrees. Supplementary angles are angles whose sum is 180. We've got this picture back from our linear pair. Angle 1 plus angle 2, the measure of these two is going to equal 180. So supplementary angles create a 180-degree angle. Complementary angles create a 90-degree angle. One of the ways to remember this is by thinking about complementary, starting with the same letter as corner. So complementary creates a corner. Supplementary creates a straight line. Complementary corner. A corner is going to be 90 degrees. Supplemental straight. Straight's going to be 180 degrees. Another way that I've seen this done is where you take the word complementary and you kind of draw like an extra line on the C. These first two letters sort of look like 90 now. That's kind of like a 9, that's a 0. So if you just add a line to the C, it sort of looks like 90. Anyway, complementary is 90. Complementary creates a corner. Supplementary is 180. Supplementary is straight. Okay, let's see if we can use a little bit of that information to solve a few problems. I'm going to scroll all the way to the back where we had some extra practice, and I'm going to work out problem number 2. We're going to use all the information here to kind of solve for x and y. Okay, the measure of angle DEG is 5x minus 4. So I need to find DEG on the picture. So I go from D to E to G. So that's going to be over here. That is 5x minus 4. And then I have GEF. GEF, that's going to be over here. And that is 7x minus 8. Finally, DEH, so that's down here, is 9y plus 5. So what's interesting here is that that one has a y in it, and the other two have x's. So we kind of have like we got to find two different variables here. Either find x first or find y first. We're actually going to find x first because these two angles are supplementary. They are part of a linear pair. I have an angle over here, it's a little smaller. I have an angle here, it's a little bigger. They are separated by one line, and together, these two angles form a 180-degree angle. They are a straight line. So, I'm going to take 5x minus 4. I'm going to add to it 7x minus 8, and together, those are going to equal 180 degrees because they are a linear pair. This is going to help me solve for x. So I'm like doing this first. Let's combine some like terms. 7 and 5 is 12. So I've got 12x and then minus 12 equals 180. We're going to add 12 to both sides. That gets me to 12x equals 192. And I'm going to get my calculator out to figure out what 192 divided by 12 is. And that will give us x. 16. All right, we need to find x and y. We have one of our answers. Okay, with this bit of information, we're able to go in and find what those actual angles are. And the reason that this could be convenient is because 7x minus 8 is vertical, meaning it's across the intersection from DEH, which is 9y plus 5. So these two are equal to each other. Now that I have x, I should be able to figure out what this angle is and then set it equal to the 9y plus 5. So again, the ones that I've got drawn in orange here, these are congruent. So let's figure out what 7x minus 8 is. Okay, 7x. X is 16. 7 times 16 minus 8. That is going to equal 94. So we have discovered that that angle is 94. I subtracted 18. Hold on. 7 times 16 minus 8 is 104. Mistyped. Which means that 9y plus 5, because these are vertical angles, is also going to equal 104. So now I can take my 9y plus 5, set it equal to 104, and solve from there. Got 9y equals 99, and y appears to be 11. So I've got my two answers there. X is equal to 16, y is equal to 11. Final answer, on to the next one. So I'm going to skip ahead to problem number 6. Looks like there's a lot going on here, and we're going to work this one out. All right. If EF bisects CEB, all right, so let's look at that first. CEB is this big angle here. From C to E to B, and EF is bisecting it. So I'm actually going to take that information right now. Say, all right, these two angles are congruent to each other. That might mean something later. Let's find out. CEF is 7x plus 21. FEB is 10x minus 3. Well, wouldn't you know it? Because those are dealing with that angle bisector, that means that these are equal to each other. They're congruent to each other. So if those are congruent to each other, just double checking my work here. EF is the bisector. Yeah. If those are congruent to each other, that means I can set them equal to each other. So the beginning of this problem is solving for x. Like anytime you see something you can set up and solve for x, do it. Follow that. So I am going to move my variables to the right and move my constants to the left. 7x minus 7x is 0. Negative 3 plus 3 is 0. That leaves me with 24 equaling 3x, which means that x is going to equal 8. All right. With x equaling 8, I can plug that back in and I can figure out what those angle measures are, because the question actually asks, what is the measure of DEB? DEB is down here. In order to figure that one out, I bet it's going to be important to know what these measures are. So that's what I'm doing next. I'm going to plug in that 8 to figure out the actual measure of these two angles. And remember, they're congruent, so I actually don't have to do this once. But I can check my work. So here's what I'm going to do. I'm going to do 7 times 8 plus 21. And I get 77. And just to be sure, I'm going to do 10 times 8 minus 3. That's going to be 80 minus 3. And guess what? That is 77 degrees as well. Hey, that means that we did that right. We got 77 on both of them. They were supposed to be congruent. They are. Now I'm trying to figure out what was DEB. What is DEB? And here's why knowing about supplementary angles is so important, and knowing about how you can create lines with angles is important, because I have CEF, FEB, and then DEB. These form this straight line, this 180-degree angle. So if I take 77 plus 77 plus whatever the measure of angle DEB is, that's going to equal 180. So 154 plus DEB equals 180. Just need to subtract 154 from both sides, and we're going to have an answer. (26). The measure of angle DEB equals 26 degrees. All right. I hope that was helpful. Obviously, we have tutoring available in the mornings. If you need some extra help, come see me. And otherwise, I'll see you in class.